According to Neil deGrasse Tyson, the most disappointing and heartbreaking Voyager discovery in the past decade was one that scientists weren't prepared for. The probe sent back troubling information from space, leaving experts restless and everyone in a tense mood. In order to investigate these enigmatic objects that Voyager had just detected, analysts and scientists detached themselves from their usual duties. We have no idea where these bizarre things originate from, or where they are going. However, we can be sure that we have never before seen anything quite like them. What are these puzzling items found by Pioneer 1? In Neil deGrasse Tyson's account of Pioneer 1, which identified 500 dark objects moving through space, we will investigate these reactions. Voyager 1 has been traveling through space for nearly 50 years, looking into places that Earth-based telescopes can't reach and making jaw-dropping discoveries. New regions in interstellar space have sprung up around Voyager 1. We are now more aware of the wonders of the universe, thanks to this engineering marvel. Recently, Neil deGrasse Tyson confirmed that Pioneer had detected 500 dark objects floating silently in space. Many scientists were shocked by this news, which sparked a frenzy as everyone began analyzing Pioneer 1's data. Experts had difficulty comprehending this unexpected discovery because something unusual was taking place. Various theories began circulating as scientists tried to piece together the mystery. Researchers might have questioned the data's accuracy if another rocket had returned this baffling information. However, Pioneer 1, a spacecraft that has been exploring the vastness of space for nearly 50 years and has surpassed our expectations, is the subject of our discussion. Much like a patient who has overcome an illness, Voyager 1 surpassed the scientists' initial expectation of a 3-year mission, spending over 45 years in space and making groundbreaking discoveries. The most fascinating aspect of the story is that Pioneer is sharing this incredible journey from billions of miles away. The last time researchers checked, Voyager was 14.5 billion miles from Earth, continuing its journey through space without any sign of slowing down. According to researchers, the spacecraft covers the distance between the Sun and Earth numerous times per year. This fact has been hard for scientists to accept, considering that one would expect the probe's speed to have significantly decreased after so many years. However, Voyager 1's most recent discoveries suggest that it is an exception. When Voyager 1 sent exciting news that would be remembered for a long time, it seemed like a typical day for scientists. Unusual space objects were discovered by accident by the probe. This shocking information explains why cosmologists were initially perplexed when they discovered data showing approximately 500 dark objects appearing out of nowhere. We went from not knowing anything about these things to experts scrambling to solve this natural puzzle in a split second. Scientists faced a dilemma because Pioneer 1 could only be held accountable. Researchers suddenly realized that the space probe was heavily tasked with finding the answers. At first, when news of this discovery broke, some scientists speculated that it could be a mistake. They believed that Voyager may have sent back incorrect data after erroneously detecting these objects. If we follow this line of thought, it seems like a plausible explanation, especially since Voyager 1 was launched back in 1977, almost 50 years of active service for humanity. One might expect that the probe's computers would have worn out and begun to malfunction, sending back low-quality information to the ground team. As interesting as this theory is, scientists have cautioned against jumping to conclusions, as it would undermine the probe's achievements. Despite the harsh and unpredictable environment of space, Voyager 1 has consistently sent back valuable data about our universe. Defying the skeptics, the probe has lasted so long due to its dual redundant computer systems. Like its twin, Voyager 2, Voyager 1 was equipped with 2 sets of command systems, data processing systems, and control systems. This redundancy has been the secret behind the probe's enduring spirit in exploring space and making discoveries. Continuous system switching, along with the ability to activate and utilize computer components, was made possible by this inherent redundancy. In order to make Voyager 1 as efficient as possible, engineers on Earth devised various strategies. This meant that the probe's instruments had to be built using simplified systems to meet time constraints and power limitations. Electrical engineers concluded that the instruments should use straightforward systems based on hardware logic. As a result, Voyager's computer systems incorporate power management and 6 onboard computers organized as a distributed system with 3 dual redundant pairs. After overcoming this obstacle, scientists still had to keep the systems running. They tackled this issue by creating a power management plan. Here's where it gets interesting. Power management involves supporting the functioning components of Voyager's computer systems. This was a challenging task, given the limited power resources on board the spacecraft. However, experts devised a strategy to monitor and optimize power usage. The scheduled shutdown of non-essential systems is one real application of these strategies for managing energy. When faced with a difficult decision, researchers meticulously identified and disabled subsystems or components that were not essential to the primary mission objectives of the probe. When looking at the radiators that were connected to some of the instruments that needed to be turned off, this becomes clear. Originally, these radiators were meant to keep the instruments at a certain temperature so they could work properly. However, in order to significantly reduce the amount of energy consumed by the spacecraft, the strategy was modified to only activate them when absolutely necessary. This decrease in energy consumption has a ripple effect. It extends the operational life of the probe. It's a mutually beneficial scenario. It's crucial to highlight that the decision to power down non-essential systems wasn't made lightly. A move like this necessitates careful consideration of the trade-offs between the scientific objectives of the spacecraft and energy conservation. In order to evaluate the impact of shutting down particular systems on the quality and accessibility of scientific data, the entire team was required to collaborate on each decision. Emotions were set aside. It was only about the current facts. The team sought to optimize energy efficiency while ensuring the spacecraft could continue collecting vital data about our universe. Engineers and scientists insisted that Voyager 1 shouldn't be hampered in any way in its quest to discover the deep secrets buried deep in space, secrets that the universe has kept a close eye on for many years. Additionally, NASA specialists are employing a variety of strategies to keep Voyager functioning in space. They also had another significant advantage to support the probe: plans for managing energy that were tailored to the constantly shifting conditions of the probe's environment were created by the group. For instance, as Voyager 1 travels further from the Sun, the available solar energy diminishes. This presents a challenge, but the experts were prepared. They made sure the spacecraft adjusted its energy consumption to account for this decrease in energy. This adaptable approach is advantageous for NASA engineers and scientists, as it guarantees that the available energy resources are effectively allocated to support the probe's essential tasks and data transmission back to Earth. There's more good news to come. Ongoing technical enhancements and updates in energy management have allowed engineers to refine the spacecraft's power system over the years. A closer look at these updates reveals that they include improvements in energy regulation and control, more effective battery charging methods, and more efficient energy distribution. Voyager 1 and its twin, Voyager 2, are now able to continue their universe exploration thanks to careful resource planning and management. The scientific community was rocked by the announcement. Neil deGrasse Tyson's announcement resonated globally, highlighting a decade of detailed investigation by Voyager 1 in the vastness of interstellar space. Unexpectedly, the probe discovered 500 enigmatic objects, their meanings and origins shrouded in complete secrecy. Moving silently through the void, this startling discovery ignited a wave of scientific inquiry. Researchers and scientists worldwide began collaborating to understand these strange objects, striving to uncover their origins and purposes. Voyager 1's significant discovery ushered in a new era in space exploration, posing new questions about the mysteries of the universe and casting doubt on previously held beliefs. The ongoing analysis of this data promises to broaden our understanding, potentially revealing new insights into the nature of the universe and our place within it. The ultimate objective remains to discover the truth about these mysterious objects and their implications for our comprehension of space as we continue to investigate the mystery. As researchers delve deeper into the 500 dark objects identified by Voyager 1, the scope of exploration has expanded. Several intriguing hypotheses have already emerged from the probe's initial data collection. These objects could be the remains of ancient astronomical events, such as fragments from exploded stars or asteroids, according to one theory. Alternatively, they might consist of materials unknown to current science, hinting at new forms of matter, or entirely new physical phenomena. Astrophysicists are employing advanced computer models to replicate the trajectories and possible origins of these objects. By analyzing their movements and speeds, researchers hope to determine if they originate from a common source, or if they emerged from various distinct events. Understanding the wider repercussions of the discovery, such as the possibility of previously unnoticed cosmic cycles, or interactions, relies heavily on this aspect of the research. Observatories around the world have joined efforts to track these objects. Ground-based telescopes are being utilized to verify and augment the information returned by Voyager 1, providing a more comprehensive view of their properties. This work focuses on identifying any chemical signatures or physical characteristics that may shed light on their nature through high-resolution imaging and spectral analysis. In addition to observational initiatives, theoretical physicists are exploring the potential effects of these discoveries on our understanding of fundamental physics. If the objects exhibit unusual gravitational effects or electromagnetic properties, they could offer insights into theories of dark matter or dark energy. Our understanding of the most mysterious aspects of the universe could be altered by these findings. Additionally, the discovery has sparked cross-disciplinary collaboration. Experts in cosmology, mathematics, and even material science are contributing their knowledge to unravel the mystery posed by these mysterious objects. This teamwork fosters a more comprehensive understanding of the data and ensures that all potential angles are explored. In response to public interest and scientific enthusiasm, NASA has begun releasing periodic updates and findings related to the ongoing investigation. These reports aim to maintain transparency and stimulate educational initiatives that engage students and enthusiasts in the scientific process. Looking ahead, Voyager 1's journey and the mystery of the 500 dark objects will likely remain a central focus in astrophysics. With continued observation, theoretical analysis, and global collaboration, scientists hope to solve one of space's most intriguing mysteries.